Hello everyone, this is RetinAI, an AI-powered assistant for retinal disease diagnosis from OCT images. In this demonstration, I'll present the main functionalities of the platform, including patient management, AI-based diagnosis, explainability tools, and role-based access control. First of all, this is our homepage. Here you can explore the several powerful features for clinicians, such as the visual explainability, clinical insights, security, and privacy. Our platform also can detect the multi-disease detection, like Trousseau, Macular Hole, and DME AMD. First, I log into the system using the administrator role. The administrator role has full access to the whole system functionalities, including user management, patient management, diagnosis history, and system analytics. Here, the dashboard page. The dashboard provides an overview of the platform, including the total number of users, registered patients, and disease and performed diagnosis, as well as the disease distribution statistics, the number of cases in each disease. In the Users section, the administrator can create new user, assign roles like clinician, admin, or researcher, and save the user. Also, you can search for users. In the patient section, the administrator can add and insert new patients. Assign the age, the sex, and the ID number. He can search also for the patients. In the diagnosis page, here we can perform our diagnosis, where the user can upload the OCT scan, choose the patient, and the eyesight. The administrator can see the predicted disease with the explainability tools. Here is the predicted disease, the confidence, the image contribution, the metadata contribution, and the risk. Here is the Grad-CAM heat map with the Grad-CAM overlay that shows the most important regions in the image that the model relied on to make his decision. Also, we have the integrated gradient heat map with its overlay, which shows the most important pixels in the image, as well as the segmentations of the different layers and the anatomical contribution, which shows the important layers in this prediction. Also, we have the interpretability card to explain to the user what each explainability tool gives as an information. The Grad-CAM shows where the model focused on, and the integrated gradients, as well as segmentation. And after we perform our diagnosis, this diagnosis will be stored in our scan history, with the patient ID, the patient name, the OCT scan, diagnosis and the confidence. Here we have a validation button where the clinician can validate this diagnosis as well as deletion. For the patients and users, we also have the actions of modifying or deletion. And if we delete a patient, all his related scan histories will be also deleted. Same thing for the users. Here's the About RetinAI page, where you can find all the information you need, and the contact page. If you have anything to ask, you can send our message to this email, and your email will be sent. We can access also the profile settings, where you can change your name and save the changes, or you can also sign out. Next, I'll log into the system using the clinician role. The clinician has access to patient management and AI-assisted diagnosis functionalities, allowing clinical workflows to be performed efficiently. The clinician dashboard provides an overview of patients, diagnosis, and disease statistic relevance to the clinical practice. In the patient section, the clinician can add new patients or update the patient's information. He can also delete patients. And here, the clinician can upload an OCT scan, select the patient, and run the AI model for automated retinal disease diagnosis. Select the patient, fill the metadata, and analyze. And he gets all the diagnosis with the explainability tools. Same thing happens. This will be recorded inside the diagnosis history table. And the diagnosis will not be validated until a clinician will validate it. He can also add a diagnosis and search. Next, I log into the system using researcher role. The researcher has access to the analytical and observational parts of the platform, allowing exploration of the patient data, diagnosis history, and disease statistics, while sensitive clinical modifications remain restricted. In the patient section, the researcher can review anonymous patient records for analysis purpose, without the ability to modify or delete clinical data or viewing their names. He can see only the metadata of each patient. And in the diagnosis history scan, the researcher can review the previous AI predictions, the associated OCT scans, and the diagnosis outcomes for further analysis and model evaluation. Also, we can see only the validated diagnosis. All this happens in the full mode, while we have another option where we can switch the mode and use the quick mode, where you can only upload the OCT scan and run the AI model without seeing any functionalities of the platform. You can run the model, insert the metadata manually, and analyze the OCT scan. And you will get all the results without anything being recorded. And that's all. In conclusion, RetinAI provides a secure and intelligent platform for retinal disease analysis, combining AI diagnosis, explainability, and role-based access to support both clinical practice and research. Thank you.